Welcome to another edition of Performance Management. In today's class, we shall continue with our lecture on linear programming, right? We shall do what? We shall continue with our lecture on linear programming. In our previous lecture, we've been able to examine the definition of linear programming, the assumptions of linear programming, then limitation of linear programming, the advantages / the usefulness of linear programming. We've also been looking at we've looked at the constraints, right? The objective function, the constraints, then the non-negativity constraint as well. Then we'll be able to differentiate when it is minimization function and when it is maximization function. So let's quickly continue with that. So we were not able to put the non-negativity constraints because of our time in our previous lecture. Then we can now include it here as non-negativity constraints. Non-negativity constraints. So x, y is less than equals to 0. Is less than equals to 0. Is less than equals to 0. So this is the non-negativity constraint. We've done that. We've finished with this part. Now, the next part we need to move into, which is the B part of this question, right? This is A. Then the B part says that determine the optimum production plan for the month and associated profit. Don't forget, from our steps, after non-negativity constraints, you convert the constraint to equation. After the equation, we plot the graph and you determine the visible region. You can now do the optimum, but we will not go there before because we will not fix, we will not do graph, right? So we need to convert it from once we convert the non-negativity, once we convert the constraints into equation, right? Because that will lead us to how to determine the production plan. So once we convert it into equation, then we don't need to plot to graph, right? So we can now pick what we want to use. But however, the A part of this question says identify the objective function and the constraint of the model to be used in determining the optimum production plan for the following month. So now this A part, let's convert this A part. Let's convert it to equation. Let's convert our constraints before we do the production plan. Let's convert our constraints. Let's convert it to what? To equation, right? Constraints. Let's convert them to what? Equation. So conversion of constraints into equation. So same that A. Let's convert it to equation. So the first one is material, right? The first one is what? The first one is material. So how do we do that? The first one is material. So we need to convert material into equation. So let's quickly bring it. You can see we have 12x plus 6y, right? So we can now say this is 12x plus 6y equals to, you equate it to, what do we have under material? You equate it to 25,000. Then you can say when x is equals to 0, what is your y? When x is equal to 0, what is y? Class. When s is equals to 0, what will be your y? I'm coming. What will be your y? So if you say when s is equal to 0, what is your y? So this will be 12. So x will be 0 plus 6y equals to 25,000. Right? 12 times 0 is 0 plus 6y equals to 25,000 hours. Alright? So therefore 6y is equals to 25,000. So what is y? Y is equals to what? When you divide it, what do you have? You have units, because this is
4,167 units.
4,000
167 units.
4,167 units. Now, please, class, confirm this figure if this is correct under material. If this is 12, if this 12 hours per unit is correct, let's check.
Yes, sir.
Okay. So 480 divided by 40. Coming?
Yes.
Okay, it's 12. Okay, that's fine. Let's move on. To do from myself, from my hand. Okay. Right. So 4,167, that is y. Now, when y is equals to 4,167, what will be your x? What will be your x? So therefore, you have 12x plus 6. What is your y? You open your brackets. 4,167. You close the brackets. Then you say equals to 25,000. Right? So 12x plus, if you multiply 6 times this, what do you have?
25,002.
Okay, I'm coming. 35,000.
25,000. 25002.
002. Okay. Equals to 25,000. Alright. So you can have 12x equals to 25,000 minus 25,000 0.002. Then 12x is equals to, when you minus it, what do you have?
Minus.
Oh, you have minus 2, right? You have minus 2,
Yes,
Abi.
sir.
That's why I say something is wrong somewhere. Something is wrong somewhere. Let's check. I'm coming. Just a minute. This 12x and 6y. Oh, I need to confirm this. 5a. I'm coming. I need to confirm Probably is from where I copied it. I didn't. Okay, yes. Something is wrong. Uh-huh. Class, can you see it? Because I noticed that something you get that thing is not normal. That is why I don't know. Even SFM student, when we are solving, if we are solving question, I will I will know that this particular question, something is wrong somewhere, right? Because before you can be able to have minus something, so it is not normal again, right? From where I copied it from, I was the one that made the mistake, right? So let me quickly go and correct it. I was looking at it. That's what happened. It's not normal again. So this is supposed to be 240. This is supposed to be 240. Class, this is supposed to be 240. So we have 480 divided by 240 and 240 divided by 240.
That will be 2x plus y.
Okay, okay. Let me quickly correct that here. 480 plus 240. This should be 240. This should be 2. Then this should be 240. Then you have 1 kg. So let's quickly go back to the constraints. This should be 2. This should be y, which is 1, right? So it's not that we can't write 1 y. Y represents 1. So we can have 2 y. So when s is equals to 0, this will be 2. This will be y. That is 1y. We can't put 1y. So we can say y. So y is equals to 25,000. Then when y is equals to 25,000, what is x? So what is x? So this will be 2. If y is y, 1y is 25. So we can change it to 25. It's better we have 0 rather than having that stuff. So what next? What's next? So we have 12. Here will be 25. So better we have 0 than negative. So if you have this, so x is equals to what? 0, right? X is equal to 0. Is that not so?
Yes, sir.
Oh, okay, that's fine. So can you see it now? That this is our x and this is our y. But we will not plot it, right? We are still in A. We just need to convert it so that we'll get what we have, right? So the next thing is, after we've done for material, we need to do for skilled labor as well. We need to do what? We need to do for skilled labor. What is the skilled labor? This is skilled labor. This is skilled labor. So let me quickly copy this. This is skilled labor. This is skilled labor. So this is equals to, you change it to equals, this is equals to 48,000. What is this thing? Coming. Okay. So I'm coming. Just need to make it bold. Okay. So we do the same thing when x equals to 0. What will be your y? So we can have 5 open brackets 0 plus 2y equals to 48,000. 5 times 0 is 0, so we can have 2y plus 48,000. 2y equals to 48,000. Then 2y. So y equals to what, class? Y is equals to what?
24,000.
24,000 units. 24,000. Right. Next, you will now still say when. You already say when s is equal to 0. Now, when y equals to 0. Right? When y is equals to 0. Okay, when y is equals to 0, what will be x? So we can have 5x plus 2 open bracket 0 close bracket equals to 48,000. So 5x is equals to 48,000. So x is equals to what? X is equals to what? What is x? Quickly, what is x? Hello? What is x? So
9,600.
okay, 9,600. Thank you. 9,600 units. That is x. So we are done with this. Then we move to another one, the unskilled. We'll do the same thing for the unskilled. Ideally, we're supposed to use this to plot graph, right? That is what we're supposed to do, right? But we're not doing that because when I checked, I noticed that it's not like that. So there's no point of doing that. So when x is equals to 0, what is y? When x is equals to 0, what is what? What is y? Right? So 2 open bracket 0, this plus 3y equals to 39,000. So 3y is equals to 39,000. So what is your y? What is y?
After 13,000.
What is y?
13,000.
13,000 units. That's 13,000. Tolulope.
Okay, sorry, sir. I just want to ask for material. when we wanted to look for when we did when we were looking for x, why didn't we just say when y is equal to
We did the same thing.
0?
We did the same thing.
No,
So
we
we didn't do
used
the
when
same
y is
thing.
equal to 5,000.
Okay. When y is equal to, this is it. We started from when s is equal to 0. What is y? Right? Okay. Oh, that's true. That's true. That's true. Oh, I'm coming. So when s is equal to 0, what is y? Right? So y is equal to 25. Alright? Then we need to look for x. We did the same thing now. Abi, I'm coming. When s is equals to, okay, we're supposed to say when y is equals to 0, what is x? Is that not so? Is that
Yes,
not
sir.
so? Okay, that's fine. Okay, that's fine. So let's quickly come back to this. When s is equals to 0, what is y? Y is equals to this. So the next one is when y is equals to 0, what is x? That is what we're supposed to do. We're supposed to say when s is equal to 0, what is y? When y is equals to 0, what is x? Right? What is what? What is x? So this should be 0, and this should be 0. Then we can now have 25 plus 0, which is 25. So 25, what do we have here?
That will be 12,500.
12,500. Thank you for the observation. So when s is equals to 0, what is y? When y is equals to 0, what is x? So the same thing applicable here. So when y is equals to 0, what is x? So we can have 2. We know we are making use of this this equation. So we have 2 when y is equals to 0. So what is our x? Plus 3 open bracket 0, 39,000. So this is 2x plus this is 0 equals to 39,000. Right? 2x is equals to 39,000 minus 0. So 2x. So divide it. X is equals to what? Quickly. Divide it by 39. What do we have? What is our x?
19,500.
Okay, 19,500. Alright. So we've done for that. The last one is the last one is the next constraint is machine hours. Right? So don't forget that ideally after equating everything to 0, we're supposed to use it to plot our graph so that we can get our production plan. But we'll not do that, but we'll just pick it from the constraints. Right? We'll pick from our constraints. So this will be equals to 0, 2x. So this will be equals to 0. Okay. This will be equals to 0. So therefore, when x is equals to 0, what is your y? So 2 open brackets 0 plus 4y equals to 50,000. So we can have 4y is equals to 50,000. So what is y?
12,500.
12,500 units. So we do the same thing when y is equals to 0. What is x? When y is equals to 0, what will be our x? Right? So we can, let me copy this. When y is equals to 0, what will be our x? So this open bracket 0. Then we can have 2x is equals to 50,000. So x is equals to 50 divided by 2. What do you have?
25,000.
Okay, 25,000. Okay, class. This is just the A part. We just needed to equate it to 0 because what the question is saying is that the constraints, and the constraint of the model to be used in determining the optimal production plan for the following month. So after you do the constraints, it's from the constraints that what you do in the constraint, that is what you will use to do your production plan. Ideally, we're supposed to use this. Like, let me repeat this again. Ideally, we're supposed to use this to plot our graph and get from the graph, we have the visible, feasible region. From the feasible region, we can get our unit from there. Then we can get our unit from there. But in this case now, we'll not be able to use this. So let's quickly go to the B part of this question. Determine the optimum production plan for the month and associated profits. What is the optimum production plan? We need to get the optimum what? The optimum production plan, right? So you can see the optimum production plan here under the linear programming is actually different from under the theory of throughput accounting or the limiting factor. But guess what? The shadow price is actually similar, right? The shadow price is actually what? Similar. So in this case now, optimum optimal production plan. Now, this optimal production plan, we're supposed to get this from our graph, right? So since we cannot plot graph here, right? We can't plot a graph. What we just do is to pick from our constraints. Class, listen, for the purpose of exam, what you just do is for you to do what? Pick from the constraints, right? Because when I checked, I discovered that most times ICANN will not tell you to plot the graph for the optimal production plan, right? But ICANN will tell you to determine the optimal production plan using linear programming. Now, the question is, how will you plot the graph? Now, what you need to do is that, since where is your constraints? I'm coming. These are your constraints, right? These are your constraints. Now, from these constraints, you can pick because is that now? My voice is low. Please confirm if my voice low.
It's actually okay.
I just sincerely I just woke up. Like seriously, I woke up around 4 something. I think 4 o'clock. Yeah. So My sincere apologies for that. Right. So just manage. Manage. Thank you. Okay. So we have to pick from this, right? Now, because all these are the constraints, right? Because this is the available, this is what we have that is available. And we said this is our constraints here. These are our constraints. Now we don't know what we will do. Do you know what you will do? Now, you can pick two. You can pick material and skilled labor. You can pick material and skilled labor. You know, when you pick material and skilled labor, they may not really relate to each other because material is 2 hours, 2 kg per unit, 1 kg per unit, 25 kg per unit. But all that you want to determine the units, right? So in this case now, you can pick skilled labor and unskilled labor. You know, when you pick skilled labor and unskilled labor, it will give you a unit. However, if you still pick material, you can as well pick, say, okay, you want to use material and skilled labor. If you pick material and skilled labor, you will still have a unit. Class, listen. You will still have what? You will still have a what? Unit. Now, since it is now based on your own discretion now to choose that, okay, these are the constraints. So you need to choose like 2 constraints that you will do the equation, because we need to do a quadratic equation. We need to do a simple equation here. So you need to choose, you know, when you want to determine production plan under the theory of limiting factor, what you did was to do, okay, you allocate it, but you can see you have more than one limiting factor here. Don't forget, ideally I would have used graph. I would have do what? I would have used graph to plot it. When I plot it in the graph, right? From the graph, I can state where the unit will come from the graph. Now, in this case, now you can decide, since we are not doing a graph, pick either you pick materials and skilled labor, or you pick skilled labor and unskilled labor, or you pick unskilled labor and machine. Just pick 2 so that we can equate them. We can do a simultaneous equation to get a unit. And don't forget that this 5x or 2x, it is per unit. Don't forget. So you can easily get unit from there, and it is equals to 25 kg. And again, skilled labor, you have 5x plus 2y, right? You have 5x plus 2y greater than 48,000 hours. Is that not so? 48 what? 48,000 hours. The 5x is 5 hours per unit. With that, you can see you can bring in your unit from there. Class, you can do what? You can bring in your unit from there. So therefore, we can decide that based on your own discretion, we can use skilled labor and unskilled labor. We can decide that, okay, if that would be the case, because there is no assumption, there is no it's part of what you should state. If the question says you should state assumption that you use, it is assumed that the skilled labor and unskilled labor will be used for the production plan, and you can decide to say, okay, material and skilled labor, whichever one you prefer. So we are picking just 2 so that we can do a simultaneous equation to get our what? To get our units, since we don't want to plot a graph. So we can quickly do that and pick from this part. So based on our discretion, which one should we pick? Based on our discretion,
The
which
first
one
two.
should we pick? The first 2. Another person, should we pick skilled and unskilled?
Yes, let's use skilled and unskilled.
Yeah, let's just use the skilled and unskilled, right? So we can decide that we'll bring them down and skilled and unskilled. So we can quickly equate this to quadratic equation. Is this okay? Simultaneous equation. We can say don't forget you have skilled and unskilled, right? Okay. Okay, let's equate this. Let's equate this. So we can have, let me quickly bring this forward. Oh, sorry. So we can have equals to this, then 2x plus 3y. Before our next class, I will still check if there is need for graph, but I've checked there is no need for graph. Class, can you hear me? I'll check again if there is need for graph, but I've checked there is no need for that. So I'll check again. So this is equation, you can say this is equation 1, and this is equation 2. If you don't know how to solve simultaneous equation, go and watch video on it too. So now, class, so which method are we using? We need to use the elimination method, right? Whichever method you feel like, class, whichever method you feel like to use, or listen, whichever method. Me, I want to use elimination method. Elimination method, I need to use maybe maybe minus two times something, right? Let's say for instance now, like I have this, I can decide to use minus 2 times 2, 4. No, I can decide to use minus 3, and yes, I can decide to use minus 3 and plus 2. I can decide to using elimination method, minus 3 coming, using elimination method. Okay, right? So I can decide to say, let me copy this. Using elimination method. So should I put the, okay. Can decide to say times minus 3. Then I'll come to this side and say times plus 3 plus 2. Or let me bring this outside. I say times minus 3. Then, so that you not think that it is another equation, times this. Can you see it? It is multiplication. Let me put it like this, times this, multiplication. So therefore, you will multiply, class, you will multiply 3 by the first equation, minus 3 times the first equation. Then you will multiply 2 to the second what? To the second equation. Class, you will multiply minus 3 times the first equation. Now let's do it. So minus 3 times 5. Minus 3 times 5, what do you have? You have minus what?
Minus 15.
Minus 15x. Is that not so?
Yes, sir.
Now, minus 3 times plus 2. Minus times plus is minus. Is that not so? So minus 6y equals to, now, minus 3 times 48,000. What do you have? Minus 3 times 48,000. What do you have?
Minus 144,000.
Minus 144,000. So the next one, multiply 2. This one is 2 times 2. It is plus. That is 4x. Right? Plus, it is plus and plus, right? 2 times 3 is what? 2 times 3 is what?
6.
6. You have 6y. Because I want to use the elimination method. 2 times 39, what do you have? 2 times 39, what do you have?
117,000.
117,000. Try this lady, you do simultaneous equation in school. Try. So 117,000. Is that also
times 39 is 78,000.
Is what?
Please, 39,000 times 2 is not 117.
Give me the
78,000.
correct figure now. If it is not, you just give the correct
78,000.
figure. 78,000. Right? You just give correct figure. If you know that this figure is wrong, right? Just say, okay, this is not correct. So this is the correct figure so that we can move from there. Right? So now, if this is established, we can eliminate this. You know, when you eliminate minus 6y plus 6y, 0. Is that not so? Is that not so, class? So, if this is 0, minus 15x plus 4x, what do you have, class? Minus 15x plus 4x, what do you have?
That's minus 11x.
11x.
Minus 11x, right? Already minus 6 plus 6 has cancelled each other. Minus 4 plus 78, what do you have? Minus 44. Minus what?
66.
Minus
That's 66,000.
66. Minus 66,000. So therefore, minus can cancel minus. X, what is the unit? Don't forget, that 11 that you are seeing there is 11 hour per unit. Then you divide it by the 66 hours, you have your units, right? So what is the unit?
6.
What is 66 divided by 11? What do you have?
That's 6. 6.
Is what? 6.
6, yes.
6.
6,000.
Okay, when you say 6, I was like, what is
So
6?
sorry, 6,000.
6,000 units, right? It is 6,000 units, right? So now, we move again. When X is equals to 6,000 units, this is mathematics, so when X is equals to 6,000 units, what will be your Y? When X is equals to 6,000 units, what will be your what? What will be your what? What will be your Y? So which of these equation are we, we need to, in our equation, we need to say when S is equals to 6,000, from our equation, which of this equation are we going to substitute? Okay, let me say substitute X equals to S equals to 6,000 in equation. Which equation? Equation 1 or 2?
Equation 1. Equation 1.
Okay, in equation 1, right? So we go back to our equation 1. This is our equation 1, right? You copy it. You paste, class. So therefore, you can have 6,000 units plus 2y, right? 2y equals to 48,000. So 5 times 6,000, what do you have? 5,000. 5 times. You say what?
30,000.
30,000.
30,000 plus 2y equals to 48,000. So we can have 2y equals to 48,000 minus 30,000. 2y equals to, what do you have? 48,000 minus 30,000. What do you have?
15,000.
Okay,
18,000.
18,000.
18,000.
Okay. Then y equals to what? What is our y?
9,000.
9,000.
9,000 units. Class, this is our unit, right? This is the unit. For those who did not understand elimination, you can use substitution, and this is the one I feel it will be easy for me. We pick from skilled labor and unskilled labor. If you have like material A, material B, you can pick material A and material B, then you move on, right? Then substitute it in the equation. Ask yourself, which of this equation is it elimination method you are using? You define it, or substitution method. You multiply it so that you have the same variable. You can see that we have minus 6 and plus 6y. From there, we have x, we substitute, we have y. Right, class? This is our production plan, but it is not over yet. The question says, and associated profit. And associated what? Profit. Now, profit. So how do we determine the profit? Determination of profit. Determination of profits, right? Okay, determination of profits. Don't forget, we already have maximization, which is our contribution, right? We already have our maximization from the first scenario, which is this. So we can have this. Don't forget, 612 is our contribution, and 465 is also our what? Is also a contribution. So pay attention. So we can have contribution from our maximization function. We can have contribution from our maximization function. Is that not so? So we can have contribution. Contribution is equals to your Naira sign 612. Let me define it. X. What is our X? What is our X unit? Don't forget, this one 612 that you calculate to, it is 612 Naira per unit. Per unit. It is 612 per unit. It is 612 per unit. It is 612 per unit. And this is maximization. It is contribution per unit. Now, our X here is 6,000 units. 6,000 units. Y is equals to, what is Y itself? 9,000, right? 9,000 units.
It's 9,000.
9,000 units. Right? So therefore, your contribution, total contribution will be equals to, bring this your function and equate it. So X, anywhere you see X, you put the 6,000 units. Let me put it like this, 6,000 units. Then this is 9,000 units. Then what is your total contribution? What is total contribution? Don't forget, this question is rich. That is why it is compulsory question. So you need to go back and study it. You need to do what? You need to go back and study it. So what do you have? What is the total contribution? Class, what is the total contribution?
7,776,000
Naira.
Naira. 776,000.
776,000. So let's check. Our fixed cost is given in this question. I guess fixed cost is given as well. So I will get our profits. I guess fixed cost is given. So let's quickly go back to the question. Let's quickly go back to the question. Let's check if we have, okay, we have fixed overhead cost. Can you see it? Per month. Please don't go and multiply it by 12 months. Oh. Class, I've analyzed this thing for you. Don't give yourself, see, don't set question for yourself. In any of these, they did not mention that it is a very big farm. They didn't mention that, oh, the production is for 12 months, this is for this. They didn't talk about 12 months or weeks. So why do you want to set question for yourself? Class. Now, the fixed cost What is the fixed cost, sir? Oh,
2.6.
2.6. Thank you. 2.6. 2.6. So 2.6. So what is the difference? So what is the profit?
5,176,000.
5,176,000. We have answered the question, which is what? The profits. Alright, so let me take this to the other side. That it will not. Where did we calculate this thing? So let me just explain. Some will think it is part of the listing. Let me just write working. Or you think it is part of the formulation. Class, I think we have answered the question on optimum production plan, right? So if you have question, you can unmute your mic and ask your question. Okay? You can unmute your mic and ask your question. Don't forget how we start. We do the production plan. From the plan, we do the profits, and this is what it gave us as the profit. So we need to go back and check again. The next question suggests ways in which, calculate the dual price for constraints identified in this scenario. Shadow price. Of course, we have like 4 constraints. We cannot calculate shadow price for all the constraints. But guess what? We have already picked skilled labor and unskilled labor. Is that not so? And skilled labor and unskilled labor is part of what? It's part of the constraints. Please listen. It's part of the constraints. And we cannot determine the dual price, which is the shadow price for all the constraints. We've already picked, when we want to determine our production plan unit, right? We already pick skilled and unskilled labor to determine the unit. Now we cannot pick all the constraints to determine dual price. So therefore, we will still maintain the skilled and unskilled labor that we use in the production in determining what the production unit.
Sir, we have 2 minutes left for this constraint.
Oh, thank you. Okay, please let me quickly create another link so that you can join. Thank you. Or shadow price is on the constraints. We already have like 4 constraints. Is that not so? So from the 4 constraints, we decided, okay, let's match 2 together for us to get our optimum production plan. Right? Okay, this is your first time. Where do you get the video? Okay. It's on the YouTube. You can just search Next Gen Professional. Okay, don't worry. I will send the playlist. Immediately after this class, I will send the playlist. I've been sending it to the platform because you just joined, right? Don't worry. Okay. Please, before I continue with this lecture, please, if you are just joining us for the first time, if this is your first lecture, unmute your mic, introduce yourself, just your name and your location.
Hello, good evening, boss.
Good evening. Yeah, good evening.
Yeah, my name is James Bola Banjoko.
Wait first. You call me boss. Your boss do your office.
No, anybody teaching is the boss now.
No, believe me, it is just an opportunity, right? So it is nothing. What I'm doing, you can also do it. No, there's nothing there. Okay.
If you have what I don't have, you are my boss. That's my own mindset.
Okay. That's fine. Please introduce yourself.
Yeah, my name is James Bola Banjoko. I'm from Lagos.
Okay.
I'm
You're
here in
welcome.
Lagos. All
Okay,
right.
okay. You're welcome, James. You are welcome to Next Gen Professional Associates. Right.
All right.
We have a YouTube page, YouTube channel. Immediately after this class, I will send a playlist that you will see all the
Okay.
lectures we have done so far from the beginning to the place that we stopped now, which is the
Okay.
linear programming. Well, we'll round up with linear programming today. Then we also have material that is going for 2,000 naira. So, and it is advisable for you to get it so that you can follow up with our lecture. Thank you.
Okay.
You're
All
welcome.
right. I'm aware of that. I will do something like that.
Okay.
Thank you so
Okay, okay.
much.
That's fine. Well done. Now, is that all? Do you have any other person? Okay. Now, if you want to determine dual price, don't forget, under the theory of either limiting factor or the theory of throughput accounting or limiting factor, dual price is the constraint. Is that also? Dual price is what? Is the constraint. And then we have like 4 constraints. We decide to pick skilled and unskilled labor to determine our production units. So therefore, when you want to, we cannot use all the whole constraints and say, okay, we want to determine dual price for all. No, we've already picked skilled and unskilled labor, right? That is part of the constraint. So what we need to do is to increase that variable by 1. We first of all, what we will do is to determine dual price for the skilled labor. What do we have? We determine dual price for the unskilled labor, right? We determine dual price for skilled labor. We determine dual price for the unskilled labor. Don't forget, when you want to determine a dual price, that is shadow price, you increase the limiting factor, the constraint by 1. Then you already have a contribution, the old contribution. Then when you increase that constraint by 1, what is the contribution? Don't forget, under the theory of limiting factor, then you now say, oh, the old contribution minus the new contribution will give you a what? Shadow price. Is that not so? That is what we did. Under what? And that is what we will still do in this particular question. Let me repeat this again. Dual prices. Dual prices. They say dual prices, not dual price. Right? Dual prices. Now, it means that we have different constraints. We already identified that, okay, labor and skilled. We use it to determine our production plan. Is that not so? Now, if we want to determine the dual prices, we pick it again. We pick the labor, the skilled and unskilled. We increase one of the skilled labor by 1 to get the contribution, the new contribution. When we are done with that, we still do the second one, which is unskilled labor. So we will now need to compare the new contribution and the old contribution with when you increase the skilled labor by 1 and when you increase the unskilled labor by 1. So that will give us what we call what? Shadow price. Now, let's start. Oh, okay. I'm coming. So let's start. Shadow price. This dual price, right? Dual price. This is the shadow price determination of shadow price. Shadow price. So now let's pick. We already have our skilled and unskilled labor. So what we just need to do, let me copy all this. Now we equate it to 1. We equate it. Okay, so this is equals to, right? This is equals to this, right? This is equals to this. Okay. Class, are we following?
Yes, sir.
Okay. So, we want to determine shadow price, class. Now, if you want to determine the shadow price, this is the hours, available hours. You increase it by 1. Okay. Let's say determination. The first one is determination or calculation of shadow price for skilled labor. So let's do that. We determine the shadow price for skilled labor. So which means that we need to increase the variable, the 48,000 hours, because that is available. You increase it by 1. Don't forget, under the limiting factor. So in this case, if you want to do it like this, let me copy this back to this. Then you increase this by 1. You put 1 here. All right? When you add 1 to this is your equation. Class, this is now your equation 1. We start again. Equation 2. Right? Now, just like the same way we did in the first equation, because we need to get the units. So once we get the units, we get our contribution. Class, we need to get units. So once we get the units, we get what? We calculate what? Contribution. Class, are we still together? We've already increased skilled labor by 1. What we want to do is to determine the contribution. Before you can determine the contribution, you need units that you will use to multiply with the contribution per unit. So that is why we need to have equation 1, equation 2. That is why it is compulsory question. Right? Now, we've already increased this by 1. What will be the unit? So we need to say multiply. What did we use to multiply that time? Oh, okay. Minus 2. So we need to do it again. Times, okay, multiply minus 3. Right? Oh, I'm supposed to use this one. Multiply, or should I put sign? Multiply, let me write it down. Multiply minus 3. Multiply minus 3. Then multiply plus 3. I want to use elimination method. So multiply plus 2, right? Which is 2. So I will use minus 3 to multiply equation 1. Then I will use minus 2 to multiply what? Equation 2. That is what it means. So I cannot bring it down. So we use it. So we multiply. Okay, let me just put it there. Times minus 3. Using elimination method, we can decide to use substitution method. Times 2. Please, who is that? Any question? Kudus?
Yes, sir. Please, why are we multiplying by minus 3? Because the equation is plus 3, not minus 3.
Kudus, did you do substitution method and elimination method in your school. Those days in this thing, it's because of the method I want to use. Kudus, you can decide to use any method you feel like. Kudus, just get X for unit, get Y for unit. You can decide that you want to use substitution method when X is equals to, you can decide to use substitution method anyhow, but I feel that using elimination method, I will understand it more better than using the substitution method. Do you understand, Kudus? Or should
Yeah.
I still start to teach? Kudus.
No, what I mean is that in
See,
using
I want
using elimination method,
yes, elimination method. Why it is because I want to have one negative and one positive. When you in class, when we treated the first one, I'm not sure.
Yes, I was.
Okay, you see what we did, Abi? -6 plus 6, one negative and one positive. So negative we cancel positive. That is why the reason why I have to say okay, because if I say -3 times 2 will give me -6. 2 times 3 will give me 6. Is that not so? -6 plus 6, 0. That is why. Do you understand the logic?
Okay.
No, not okay. Did you understand the logic? You don't.
So no, what I mean is that in mathematics,
Okay.
if you are using elimination method,
Okay.
if you are using elimination method, we are going to
Okay.
multiply by +3 and multiply by +2. And
No,
according to the rules of elimination method is that if the sign is the same thing, you subtract, but if they are different sign, you add.
No, I decide. So that is your own approach to mathematics. See, Kudus, use that approach to get what we will get now. Kudus, can you hear me?
Yes, sir.
Use the approach. Let's see what we will have. I beg. Eh?
Okay. All right, sir.
Yeah, follow on, sure. Follow on,
Yo,
sure.
it has been corrected. I just want to point your attention to 48,000.
Okay.
And one.
Okay. That's fine. That's a very good one. Well done. Now let's multiply. Kudus, use that method. Use it to anything. Just get X is equals to unit. And see, just get and move on. Right? Get it and do what? And move on. So let's continue with our lecture quickly. When you multiply -3 times 5, you have -15x plus times minus -6y equals to -3 times 48,001. What do you have?
-144,003.
Okay. Minus 144,000 what?
003.
Okay. So next, you multiply this will give you 4x, right?
Yes,
3 times
plus
2
6y.
is 6 plus 6y equals to, if you multiply 2 times 3 times 9, 78,000. Right? So now you can see now, produce. Plus can cancel plus. Minus can cancel plus, right? -6 plus 6y. That is the purpose of me using elimination method. So use any method that you feel it will be convenient for you, right? All in all, get x, calculate x, and calculate what? Y. Class, are we still together? Are we good? Okay. Okay. So if this is established, right? You know, this is mathematics, so interesting. -15x plus 4x. What do you have? -15 minus 4. What do you have?
Minus
minus 11x, right?
Minus
So,
11.
okay, thank you. Minus 6y plus 6y
Check
cancel
sir.
each other.
Sir. Sir, is it
What?
minus 15 minus 4 or minus 15 plus 4?
It's minus 15 plus 4 now.
Okay. There is minus 11x.
Okay, that's fine. Because you already used minus 3 to multiply already. So you don't need to consider all those things. Just like what this guy just said. I just want to have a straightforward way of calculating the elimination method. You can use any other method you feel it will be convenient for you, right? Because we have minus 15. You already used minus 3 to multiply. So you don't need to consider that minus sign. You can just say minus 15 plus, this is 4s, minus 15 plus 4s. You move on. Minus 44. Now the next one is minus 44 plus 78. Minus 44, 003 plus 78. What do you have?
That's 66003.
Okay, 66003. Minus 66, right? Minus 66. So minus can cancel minus, right? You can have, what is your x? What is x now?
That's 6,000.27.
6,000.27. Don't forget, under linear programming, the assumption is that one of the limitations is that you can produce a fraction under the linear programming, right? You can produce a fraction. So that is why you don't need to even mind the approximation. You move on like this, right? Then, when substitute x equals to 6,000.27 units in equation 1, right? Or which equation? In equation, which equation? In equation, class, which equation are we substituting?
Can you see? That's one.
Yeah, I have to use 2. Yes, because we already increased one by 1 unit. So I have to use what? I have to use 2. So substitute it in equation 2. That's fine. That's a very good one. Coming. That's a very good one. In equation 2, why? Because we already increased equation 1, right? By 1. So equation 2. So what is our equation 2? This is, let me just copy. This is equation 2.
4x.
Okay. No, not 4x. So not 4x. So this is
No, it's
equation
2x.
2. Yeah, it's 2x. Please, so if you don't understand the elimination method, I beg you in the name of God, please use substitution method. Probably immediately after this class, you can go and watch video on elimination and substitution method. If possible, I beg. So 2, open bracket, 6,000.27, right? Plus 3y equals to 39,000. That is why it is compulsory question, right? So when you multiply, what do you have?
That's 12,000.54.
Okay. 12,000.54, right? Then plus 3y equals to 39,000. Therefore, 3y 39,000 minus 12,000 0.54. So 3y equals to, when you minus it, what do you have?
You have 26,999.46.
26
999.46.
999.46. Okay. So in this case, what is our y? Y equals to what?
Y is 8999.82.
8999.82. Please, others should confirm this figure, please.
Okay, sir. If I actually use the equation 1, I still have the same answer, so you can still use the equation 1 too.
Okay, thank you, mathematician. Okay, that's fine. Next. So, class, are we good? This is our x and this is our y, right? This is our x and this is our y. Class, we have increased it by 1. We're able to get this, then we multiply, right? And we have our x and y. So the next step is to determine the contribution, total contribution, right? Okay. Total contribution. So don't forget, we need to bring in our function, objective function, so that we can get contribution. Let me bring it here. Don't forget it's contribution, right? It is maximization. So x is equals to, what is x? Let me copy it. This is x, and y. Please, I beg you in the name of God, Abi, please, let me just plead with you now. From now till 1st of April, I don't expect anyone in this class to miss. Please don't even try it to miss class. If you miss class that day, if that video is being uploaded, go back to the YouTube and watch it. Do you know why? Do you know why? Because from now till May, we'll be doing more important topics. Not that what we've been doing is not important, so don't quote me wrong. But it is necessary. From this, we will move to transfer pricing. From transfer pricing to pricing decision. From pricing decision to budgeting. From budgeting to variance, then we are good. So you can see how important it is. Very important. Please don't even try it. If you miss lecture, go back to the video. Go back to the YouTube and watch, please. Now, the y, what is y? This is the y, right? This is the y. So therefore, this is maximization, right? Which is the total contribution. Total contribution, let me write it again. Total contribution. Let me write it again. Okay. Total contribution. Right. So this is the maximization. X is what? What is our X? X is 6,000 0.27 units. So what is y? Y is 8999.82 units. So class, what is the total contribution?
7776.
I'm coming. 7776.
083.16.
083.16. Okay. So if this is the contribution, right? Now, this is the new contribution. As a result of, this is the new total contribution as a result of increase in one's scarce resources. As a result of increase in what? In a constraint of skilled labor. Now, don't forget, you just need to bring in the old contribution, whereby the old contribution that we did not increase anything by 1. Class, you need to do what? You need to bring the old contribution that we did not even increase it by 1. So the difference between the new total contribution as a result of increase in the constraint and the old one, we give you the difference, we give you what we call a shadow price or a dual price for skilled labor. We'll do that for unskilled labor because the question says dual prices. So we need to do, when you increase the skilled labor by 1, you go back and do the one for what? Skilled labor, for you to get the what? The dual prices for each of the constraints. Now, we go back and check. What is the old contribution? Old contribution. We quickly go back and check. So this is the old contribution. Old contribution. Right. So the old contribution is this. This is the old contribution, class. So the difference, what is the difference between these two?
83.16.
Thank you. Shadow price or dual price, right? The shadow price or dual price is 83.16 naira per unit. Distinguished professional colleagues, this is the dual price when you increase skilled labor by 1. So we need to do that for the second one. So before I continue, I need to look for the same application for this for the calculation of shadow price for skilled labor. I will do the same thing for the unskilled labor. But before I continue, do we have anyone that have question? If you have question, quickly unmute your mic. If you have question, unmute your mic. If you don't have, okay, let's move on quickly so we can go. Okay. Okay, sorry, just a minute. I'm just trying to. Okay. So, James.
Sir, in my own calculation of shadow price, what I'm doing here, the first 1 instead of 8999.82 that you got. I got 83. Is anything wrong with that?
No, there's nothing wrong with that.
Okay.
There's nothing wrong with that. Hold on. So let's move on, right? So the shadow price of the unskilled labor. So I can equally copy all this. Wow. That is why it is compulsory question. Can you see it? Oh. Unskilled labor. Skilled labor. Right? So we need to increase this by 1. Then this will be 0. This will be 1. Right? So I can equally copy this part, but the only difference will be the final one, right? So let me just copy all this. We'll change it. Hopefully we'll not make a mistake. Okay. So minus 3 times 48,000. Minus 3 times 48,000, what do you have? Minus 3 times 48,000. Hello? Hello?
Sorry, that's minus 144,000.
Minus 144,000. So 2 times 39,001. 2 times this. 2 times this. 2 times this.
78,002.
78,002. Now, we already used minus 3. Minus 3 times 5 is minus 15. Minus 3 times 2, minus 6. Minus 3 times 48,000, minus 44,000. 2 times 3, 2 times 2, 4. 2 times 3s, 6s. 2 times 39,001, 78,002. Are we still together? So, minus 44, minus it. What do you have? Minus 44, 78. What do you have? When you minus it, what do you have?
That's minus 65,998.
Minus 65,998. So what is your x? X is equals to what?
That's 5999.82.
5999.82. This is the unit. 5999.82. This is the unit. All right. So substitute x.
Sorry, sir. Can we just round it to 6,000?
No, you can't round it up. Who is that? Is it James? Is it James that said we should round it up?
No, it's not James.
Okay, have you been in our classes before now?
Yes, I've been in this class before now. I was just thinking, since unit is a whole.
You please, you will lose mark if you are thinking that way. In linear programming, you can produce a fraction. I've said it several times, even in the introduction of linear programming. Under the limiting factor, you can produce fraction. You can approximate. So please, Temidayo. So substitute x substitute x equals to 999.82 units, right? In either of the equation 1 or 2, because Kudus have actually helped us to confirm that we can use any of the equations.
Let's use one.
Equation 1. So this is our equation 1. We copy it. So x, anywhere you see x, you put the figure 5999.82 units. You close the bracket plus 2y equals to 48,000. Okay, so when you multiply this, what do you have?
That's 29,999.1.
0.1. So plus 2y equals to 48,000. So 2y equals to 48,000 minus 29,999. You say point what?
0.1.
10.
Okay. 0.1. So 2y. Please just give me final figure. Y equals to what?
9,000.45.
9,000.
0.45.
0.45. Right? 0.45. So this is the unit, and this is the unit for this. So therefore, we can now copy it down just the way we did the. We can now copy all this. Total contribution. So x now we change. Oh, wow. S now we change to 5999.82. Y we change to 45. Y we change to 9,000. So therefore, we can substitute, right? So let me quickly copy this without wasting much of our time. Wow, I'm tired. You can see it's kind of stressful, right? You know, that is why it is compulsory question, right? So I can want to they want you to think, how will you calculate shadow price under the linear programming? Please master this. Please master it. X is 5,999.82. Then this is 9,000.45. Class, what do you have? What is the new contribution?
7776. 095.
I'm coming. 776.
776. 095.
095.04.
0.04.
So what is now the shadow price?
95.04.
95.04. Oh, class, we are done with these parts again. And It is as simple as ABC, right? The question is abducted from ACCA as well as ICANN. So what if linear programming is your compulsory question? Last diet was variance analysis. Before last diet was limiting factor. What if you have linear programming? Nobody knows. Now, that is all about this part. And these are the shadow prices for the unskilled as well as skilled labor. So let's quickly go back to the question again. And, imagine 10 marks. This is 10 marks, which means the one you calculate for skilled could be 5 marks, right? The one for unskilled is another 5 marks. That is 10 marks total. That is interesting, right? Lastly, suggest ways in which the management can overcome the capacity constraints. Identify above during the month and the cost implication. Class, how can they overcome these constraints? To me, for them to overcome these constraints, they can just probably they operate on the just-in-time system, right? Then I'm coming. Let me just bring up that part. So suggest ways in which the management can overcome the capacity constraints, identify above during the month, and the cost implication. How can they overcome all these constraints? Well, it's for them to actually work with their capacity. And that is just the truth about it. If that is not enough, they could operate in a just-in-time system, whereby you can only produce when you can only produce when it is demanded. But let me put something down here. E parts. Coming to E, right? So how can they overcome the constraints? They can do that by investigate alternative sources of material. They can seek another such as sources more necessity, overtime hours and bonuses, right? For them to overcome the constraints, they can decide to increase operating hours of machineries. They can decide that, okay, they want to engage in overtime, right? So that they can be able to achieve this objective. So how can they overcome these constraints? If they can do that, they can actually work overtime, right? So, class, I think I'm tired and we need to go. Eh, 9 minutes. Class. Hello.
Hi.
Like, go and suggest. When I send the material to use, go and suggest. It is tiredness.